And now let's look at the geometric average return, the last question. So we have our prices, they were given. We have just calculated the returns in percent, in decimals, which we use to find the arithmetic average. Let's look at this information a little bit differently. In year one, the stock price was $50, right? How did we get 50? Using the return that we calculated. It's like saying that you paid $100 today in year zero, then you multiplied by 1 plus the return over the first year, which is negative 0.5 or a 50% decrease. And that formula is, this formula is how you go from $100 to $50 in year one. Now, year two, stock price drops to 100, which is given, right? It's as if you are saying that you started with $100 in year zero, and then you multiplied by 1 plus the return in the first year times 1 plus the return in the second year. So it's like doing the future value calculations. Remember FRL 300, chapter 5. Future value is the initial amount multiplied by 1 plus the interest rate R. It's exactly what's going on here. Why is it not 1 plus R? Why do we have two multiplication terms? That's only because the return is not the same every year. It's a 50% decrease in year one and a 100% increase in year two. So we write them down sort of separately. Now, year three, stock price is 200, which is given. We can go to $200 by taking the original 100 in year zero, and once again, just like what we did for years 1 and 2, we can apply the future value sort of principle and multiply the initial $100 amount by 1 plus the interest rate over the 3 years. But we do them again one by one because they are different numbers. Same for the final fourth year. $150 given for the end of year 4 of our investment could be reached by taking the initial amount, $100 today, and multiplying by 1 plus the return in year 1, negative 50%, times 1 plus the return in year 2, 100% increase, or 1 in decimals. Same again in year 3, and a 25% decrease in year 4. So times 1 minus 0.25, right? Okay, what is the geometric average return? It's as if we are looking at these 4 different returns over the 4 years, right? And it's as if we are forcing them to be the same. If we force these 4 numbers to be identical, what would that number be? The same for each year. That would result in $150 investment value at the end of year 4. That's the geometric average return. So if the return is forced to be the same every year, then we don't need to have those 4 multiplication terms. We can have it only once and add the power 4, right? Okay, let's calculate it. This is what we have. Then we can get rid of the power 4 by dropping it on the left hand side, and on the right hand side we add the power 1 divided by 4 to everything on the right hand side. Then we want to get rid of 1. We drop it here on the left hand side and instead move it to the right with the opposite sign, minus 1. The rest, plug and check, calculate the answer to this complicated term. And if you do it right, maybe it will take you a little bit of time, you should get 10.67%. This is the geometric average return. So it's like the average of the 4 returns. But it's a slightly different interpretation from the simple average or the arithmetic average. 10.67% here means if you invest your money for 4 years, we are no longer saying for 1 year, for 4 years, the entire investment period. Your annual return would be 10.67% on average per year, right? Annual return, compounded annually. I completely agree that this is all very, very confusing. Let me explain it a little bit differently. Let's go back to what we were given. We were given $100 per share in year 0, right? It's as if we are saying that after the first year, our money grows by 10.67%. If we use that for our return, then we will have $110.70 approximately. Then our money grows by another 10.67% over the second year, right? As if. In which case, at the end of year 2, it's as if we have 122.5. Same in year 3, same in year 4. Guess what we get as a result? $150. This is what we were given, right? Except if you go back a few slides, we had this very jumpy, bumpy road to go from the initial $100 a share to the final $150 per share, right? We basically smooth it out. We remove all these ups and downs, bumps, right? And we are forcing the return to be such that we have this gradual increase in our money, smoothly going from 100 to 150, right? And because this return repeats every year, as if it repeats every year, part of our definition of the geometric average is compounded annually. And we have to specify the entire investment period, all 4 years in this particular example. By the way, there's another way to do this math, and you might really like it. Let's bring up the financial calculator. You can actually do it in the financial calculator. Let's turn it on. So essentially we are saying that we are starting with 100 and 4 years later we have 150. So it's as if $100 is our present value, right? Typically we are taught to set it to a negative value. So after pressing 100, I then press the plus/minus key to set the value to negative. And then I press the present value button, PV. 150 is what I will have in the future. That's like my future value. I press 150 and then the future value button, FV. How many years apart are they? 4 years. That's my N, number of years. I press 4N. And guess what I need to calculate in the calculator in order to find my geometric average annual return? That's right. All I need to do now is compute the interest rate. I press compute IY, and that's my answer. 10.67% per year, right? That's what it all basically means, and that's how it all kind of comes together. There's another way. So the good thing is, yeah, you can use this trick in the financial calculator. But the bad thing is, usually you're not given the dollar amounts, which you can use for PV, FV, and then compute the IY. Usually you are actually given, you're given the returns. So usually a numerical problem on this topic starts by giving you the returns in percent, like minus 50%, 100%, 100%, minus 25%. And then what do? What are your dollar amounts? So there is another trick how you could do it in the financial calculator. Let's clear everything and start all over again. Let's say you have $1 today. That's your starting point. That's your present value. 1, set it to negative, PV. 1 year later, your return is negative 50%, right? So 1 is your N. 50% negative is your return, IY. How much will you have from your initial $1 at the end of the first year? Compute future value, 0.50. Kind of matches what we have, right? So that's at the end of year 1, right? So now I'm showing you in general how you could use the financial calculator to find the geometric average. So step 1, PV equals 1, like $1. Take the return that is given for year 1, use it as your IY, and compute the future value after 1 year. You got 0.5. Now, this is the PV for the second year. Change it to negative, hit PV, 1 year later, so 1N, with the return of 100%, so 100 IY, what will the future value be? Compute FV. We have $1, right? And that's what we had. We are going back to where we started at the end of year 2. Now repeat that 2 more times using the returns of 100 and minus 25% for the remaining 2 years. So I wanna set this now to be my PV for the third time. So plus minus PV, 1 year later, 1N, 100%, another 100% return, so 100 IY, what's my future value? Compute FV. And last time, this becomes my PV. I can change the sign to negative and hit PV button to save it. So plus minus PV, 1 year later, 1N, minus 25% return. I press 25, then plus minus, and then IY, and I'm computing future value, 1.5. So at the very beginning we had 1, now we have 1.5. So you can write these two numbers down. The first one would be always 1, and then write down 1.5 that you found after year, 1 year at a time, entering the returns that are given to you in your problem. So we have 1 and 1.5. Now we can start all over again. So 1 plus minus PV, 1.5 is my FV. We have 4 years. We had 4 returns that were given, so that's our N, 4N, and we are computing the implied return that makes the smooth transition from 1 to 1.5 over the 4 years. So I'm computing IY. Same result, 10.67, right? So this is a good trick when you're given returns already. There are no dollar amounts at all. So you use each return one by one to find the future value 1 year at a time, and you can start with the initial amount of $1. Write down what you have after 4 years, the future value at the end of year 4, and then 1 is your PV. What you have for the future value in year 4 is your FV. How many returns you used is your N, and you compute IY. That's your geometric average. Okay, so where were we? We were right here. So I showed you basically 3 different ways to find the geometric average. 1, we actually used this formula. 2, if you know the dollar amounts, which is where we started this entire problem, then $100 is your PV, $150 is your future value, 4 years in between, that's your N, and you're computing IY in the financial calculator. And the third method I've just shown you was if you don't know any dollars, you just know the the 4 returns, right? You can use them one by one to find future value 1 year at a time, and then the last future value is your FV, 1 is your PV, they are 4 years apart, 4 is your N, compute IY. Same result. Okay, so to summarize, in this particular problem, the arithmetic average was 31.25%. The geometric average was 10.67%. Completely different results, and their interpretation is a little bit different. Let's do a couple examples. Before that, you might be wondering, okay, how do we know which one to calculate? Well, that's always given. Okay, but in real life, which one is more appropriate? Should we always calculate both? How do we know which one is better? Typically, the arithmetic average is more appropriate for very short-term investments. Like you only want to invest your money for a couple of years. And then it's good enough to just find the simple average, which is what the arithmetic average is. The geometric average is more appropriate when you plan to invest your money for several years or many years, so for long-term investments. The rule of thumb that the book recommends, arithmetic is good enough to use if you invest for under 20 years, because in real life the arithmetic and the geometric results would be so close that it's not worth it calculating the geometric one. The geometric one is definitely the one to use if the investment period is longer than 40 years, because it's a very different number from the arithmetic average. And the book says that split the difference if your investment period is somewhere between 20 and 40. In this class, on the exams, in the homework assignments, you probably will never see more than 6 returns that are given to you. So a 6-year investment project. Okay, couple of quick examples. By the way, this is the general formula for the geometric average. Only use it if if you think it's easier than doing it in the financial calculator. And remember, I showed 2 ways to do it in the financial calculator.